Alright, the next 3 chapters are all about gathering data. And one way we can gather data is with simulations. And chapter 11 deals with simulations and specifically understanding what it means to be random. Alright, the point of these next few slides, and normally I do this in class, but is to make the point that you are not random. We are not random people. Every decision we make is based on something, past experiences, preconceived notions, knowledge. It's based on something. We are not random people. So, what I would typically tell my class is to not say anything. I'm going to go to the next slide. And then, seriously, don't say anything. Keep this all in your head. Okay, what I'm going to do is I'm going to show you some numbers, and I want you to pick a number at random. I want you, and I just told you you're not random, so I just want you to pick a random number, okay, from the numbers on the screen. Look at the numbers quickly and pick one, but don't say your choice out loud, especially if you're with some other people. You ready? Here we go. Alright, do you have your number picked? So check this out. What number did you pick? Well, studies show that almost 75% of people pick 3. Every time I do this in my classes, about 3/4 of the class picks 3. 20% of people will pick 2 or 4, so 1 in every 5 people. And then if you picked 1, you're an oddball. Only about 1 in 20 people pick 1. So the point is, you're not random. Even though I asked you to pick a random number, 75% of people would pick 3. And if it was truly random, it'd be 25% for each number. So here is a, funny Dilbert cartoon. It's about a random number generator, and he keeps saying 9, and technically that could happen. It's not likely, but it could happen if it was purely based on randomness. The way we are going to get random numbers is through computers or from books. Okay, we have calculators that are going to generate random numbers for us. These random numbers aren't really random, but they seem random to us. They're based on an algorithm. On the AP exam, you will be expected to use random number tables, which is what I would call books. There are published books of random numbers, which is insane, I know. But we need these things to run simulations. They also use the timing decay of radioactive elements, lava lamps, and then some random websites. Random. But if you can look up these websites, and they'll give you random numbers as well. Alright, even shuffling cards is not random. Sort of. A scientist or statistician, I guess, actually discovered that if you shuffle a deck 7 times, then it randomizes the deck. I guess you have to actually shuffle it well, because some people would probably require more shuffles than 7. But if you are shuffling it well, or you're using a shuffler, anything less than 7 actually leaves order in the deck, and more than 7 doesn't make it any better. Alright, so this is what it will look like on an AP test, using random numbers to get a simple random sample. If there are 80 students in Mr. Curry's classes and I want to select a sample of 5, how would you do it using these 15 numbers? Because this is how it's done. When you generate or you get a table, they give you random numbers in groups of 5. Okay? And so the question is, how do you use these random numbers that are in groups of 5? Well, if I have 80 students, I'm probably going to assign them numbers starting with 1, 2, 3, all the way up to 79 and 80. Okay, so if I give every one of my students a 2-digit number, I could then go and split these numbers into groups of 2. So I would pull student number 5, student number 16, student number 62, student number 93. I've already pulled student number 5, and then I don't have a student number 93. Whoops. So I would pull student 77 and 48. So if you get to numbers that you don't need, you just skip over them, X them out. If you get to repeats, in this case, a repeat is not a good thing. So I'm going to exit out. And my students that I will pull are student number 5, 16, 62, 77, and 48. When you take an AP exam, if you have an FRQ based on random numbers, make sure you write on your random numbers to show what you're doing. Alright, so a simulation models a real-world situation by using random digits to mimic the uncertainty of a response. So, for example, if I want to mimic having a boy or a girl, we randomly generated zeros and ones. Zeros for girls, ones for boys. When we wanted to mimic opening cereal at the beginning of the year, we generated numbers 1 through 10. 10 was a Pikachu, 8 and 9 was a Charmander, 1 through 4 was a Squirtle. So when you use random digits to mimic responses, that's called a simulation. Let's see. And generally, the reason we do simulations is because it's much better to do simulation. It saves money. It saves time. If you were building a bridge, you really wouldn't want to build the bridge first and then test it. You would want to run a computer simulation. It's kind of the same thing. Every time you run the simulation, it's called a trial. So here's the simulation. You want to take a quiz, 6 multiple choice questions. After you study, you estimate that you have an 80% chance of getting any individual question correct. So how do we use random numbers to simulate this? They're going to ask you this type of question on the AP exam. So the way I would answer it is 0, 1 through 80 equals correct. And then 81 through 100, or in this case, that'd be 00, is wrong. Okay, so you have to describe how you do it. I could have just as easily said 00 to 79 is correct, and 80 to 99 is wrong. The key is that this is 80%, so 80 out of 100 needs to be correct. Another way to do this that I was an idiot for not thinking of, 1 through 8 could be correct, and 9 and 0 could be wrong. That's actually a much easier way to run the simulation, so I think I'm going to do it that way. And so then the questions, what are your chances of getting all 6 questions correct? Base your answer on at least 20 trials. So I'm going to do it using this method up here. 1 through 8 is correct, 9 and 0 is wrong. So the next slide is a simulation. The next slide is random numbers, and you have to use random numbers from the table they give you on the AP exam. If we weren't using a random number table, I would say just use your calculator. Alright, so here's a 20 by 20 table of random numbers. I'm going to just use the first row. Okay, and again, we're taking a 6-question multiple choice test. So 1, 2, 3, 4, 5, 6. So we got, remember, 1 through 8 was correct. So 1, 2, 3, 4, 5 correct. And then the next one, 1, 2, 3, 4, 5. Got correct, 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 incorrect. So again, I got 5. Okay, 1, 2, 3, correct, 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 correct. All 6 are correct. 1, 2, 3, 4, 5, 6. Okay, all 6 are correct. And all 6 are correct. So we're supposed to do 20 trials, right? So that's 1, 2, 3, 4, 5. So I'll come down here and do another row. So we got 2 wrong, the zeros are wrong. So it's 4, 5 correct. Remember 9's, oh gosh, this is a bad one. Only 2 correct. 5 correct. 5 correct. So we've done 10 simulations. Okay. Okay, so there's that 9 again. So we got 5 correct, 6 correct. We got 2 wrong, so 4. 2 wrong, there's 4. Another 2 wrong, so 4. Okay, and then I got 1 wrong, so we got 5 right. 1, 2, 3, 4, so 2 right. 4 right. Another 4 right. And all 6 right. So based on 20 trials, we got all of the answers correct. 1, 2, 3, 4, 5. So 5 out of 20. 1 out of 4. So according to our simulation, there's a 25% chance that if you study, you'll get, and there's an 80% chance that you get a question correct. Then there's a 25% chance that you'll get all 6 correct. Alright, so if you want to think about it, there's really 7 steps for building or designing a good simulation. First, figure out what needs to be repeated. Having a baby, opening a box of cereal. In the last one, it was answering 1 question on the test. You have to explain your model, so I explained that 1 through 8 was correct, and actually I said 9 and 0 was incorrect. Explain how you will combine your components to make a trial. So the last one, the multiple choice, 6 random numbers made up your trial because there were 6 questions on the test. For the Pokemon example, you just kept going until you got one of each type of Pokemon. Figure out what your response variable is. What are you trying to learn? In this case, or in the last case, I was trying to figure out of 6 questions, how many did you get correct? Run several trials. So I ran 20. Collect, summarize the data, state your conclusion. Pretty straightforward. This is kind of important. Simulation technically is always wrong because it's not the real thing. So don't make it seem like this is what will always happen. It's just based on the simulation. There was a 25% chance that I was going to get all 6 multiple choice correct. Alright, so if we went back to the multiple choice example and you have a friend who doesn't study, okay, he just says, hey, I just guessed blindly. So the question is, do you believe him? If each question had 4 possible answers Explain how you use random digits to determine whether someone gets it right or wrong. So, in this case, it would be really easy to say 1 is correct and 2 through 4 is incorrect. So there's a 1 in 4 chance that you get it right. The problem is, that means if we're using the random number table, which we could do it this way, anytime we saw a 5 through 9 and then a 0, we'd have to skip it. And that's just a lot of numbers to skip. So I think with the way I'm going to do it is I'm going to say 1 through 25 is correct, because that's a 25% chance. And then 26 through 99 and 00, which will be 100, is wrong. Okay. I'm going to take them in groups of 2. I'm going to get 6 questions, and then that'll represent 1 trial. Okay, so here we go. Okay, I'm going to start on row 8 this time, just to change it up a bit. Okay. So again, I'm taking them in groups of 2. So there's 1, 2, 3, 4, 5, and then first trial. 1, 2, 3, 4, 5. Second trial. 1, 2, 3, 4, 5. There's third trial. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Okay, so let me start counting. I know I don't have enough, but I think you'll get the point. Alright, so we said 1 through 25 was correct, so ooh, that's a horrible color. Okay, so incorrect, incorrect, correct, incorrect, incorrect, incorrect. So you got 1. Okay. Wrong, right, wrong. Wrong, wrong, wrong. Got 1 right again. Correct. Correct. Now we got a 0, 7, so that's correct. We got 3. Oops. Correct. Correct. Got 2. Got a crying baby. We're at 3. And we got 2. So I'm not going to run any more trials. That's 1, 2, 3, 4, 5, 6 out of 6 trials. We weren't even close to getting all 6 right. So I'd say your friend is full of baloney.